What's up guys, welcome to Tank Control Games. This is episode 2 of my Resident Evil style camera system series. If you didn't catch the first one, I definitely recommend watching it before you proceed here because we're going to be using everything we did there as a foundation. In the last episode, we created our basic camera triggers so we could switch between 2 fixed cameras and added support for camera-based controls. In this episode, we're going to be expanding that system even further and creating 2 new camera types, a tracking camera which will rotate to follow the player wherever they move, and an on-rail camera which will attach to a spline and follow the player with an offset. That'll be something similar to what you might see in Resident Evil Code Veronica or the Silent Hill games. So if that sounds interesting to you, make sure you stick around for the full video. This is going to be on the longer side, but I promise you it'll be worth it. There's just a lot to cover. So let's get started. Let's open up the content drawer and navigate to our blueprints folder. You'll see our BP camera trigger that we created last time. The logic in here is not really going to change. We're going to do a few small tweaks, but we'll get to that later. So before we do that though, let's create 2 new blueprint actors. So right click, Blueprint class, actor. Let's name the first one BP_camera manager. And then this blueprint's going to act as the brain of the whole system. It's going to control which camera is the active camera, and then based on that, we'll trigger some other logic. So you can right click that and do duplicate. And then for the second blueprint, let's name it master camera. And this is going to be the parent blueprint for all the cameras moving forward, and it will replace these cameras in the scene eventually. So let's save both of those. And then if you could double click Camera Manager open. We'll start with this because it's really simple. So this is only going to have a single function. So actually if you go under the Functions tab, just click plus. And then name your new function SetActiveCamera. This is the only function we really need. So compile. And then if you click on the node for SetActiveCamera, we can click an input. Let's name our input new active camera, and then it defaults to Boolean, but we're going to change this to be of the type master camera, which is the actor we just created. And then we need one other variable, so let's click the plus button under variables and name it current active camera. And this will also be of type master camera. Cool, so that looks good. Let's drag current active camera into the graph. And then the first thing we'll do is check if that is valid. And then if it is valid, let's check if the new active camera is not equal to the current active camera. And then add a branch. So when that is true, then we just want to set the active camera to be the new active camera. And then you can add some reroute nodes just to clean this up a little bit. You basically just need to highlight any of the lines and then double click and it'll create that node, and it just lets you keep things organized and clean. So that looks good. Last thing after we set the camera, we also just want to enable tick for the camera. So drag off our previous node and do set actor enable tick. And this is just a performance consideration. You just don't want a lot of ticks running on all of the cameras at once. So to keep things performant, we're just going to only enable tick whenever a camera becomes active. So one other thing we can do now is open up our master camera, do open full blueprint editor, and then go under details and just search tick. And then where it says start with tick enabled, just uncheck that. Compile and save, and then back into our camera manager. So this looks good. And then one last thing we need to do here is when the active camera is not valid, we just set the new camera to be the active camera, and you just want to do that right away. Basically just if there is no active camera, just instantly set it as the new active camera. That looks pretty good. So I think the function here is done, so do compile, save, and that's really all we need for the camera manager. Like I said, super easy. Now we'll move on to the master camera logic. This one's going to be a little more complicated, but we'll start with the begin play. And actually, even before that, we'll just add our components first. So this is going to have a couple different components. So if you do under the components tab, the add button, we're going to start with spline. And we also want a scene component, camera, and a spring arm. So that's all of our components. but the hierarchy is not what we want right now. So first, where it says sync component, right click and rename to rail pivot. And then drag the spring arm on top of rail pivot, and then drag the camera on top of spring arm. So that should be the order. It should be rail pivot, spring arm, camera, and then spline is just its own thing independent of that. Under the spring arm, for now, let's just set the target arm length to be 0. So it's kind of in the center of the viewport there. And that'll be good for now. We're gonna do some tweaking of that later on, but for now I think this should be good. So that's all of the components done. We also want to go into the event graph and now set up our BeginPlay. So what we want to do in here is, first and foremost, we want to get a reference to our camera manager. So get actor of class. And then under the dropdown, search camera manager. Okay, let's drag off the return value and do promote to variable. I'm gonna call this camera manager reference. So before actually setting that reference, let's also check if the camera is valid. So if the camera manager exists in the scene, then it would be valid and we will set the reference. If it doesn't, we're just gonna print a debug message letting us know that. So do print string, let's just say error, no camera manager found in scene. And just make that red so that we know it's an error. You just want this because the camera manager is super important to the whole system working. So if it's not dragged into the scene, pretty much nothing will work. And you just want a quick message that lets you know that. So if we click play, we'll see our message in the corner. And then we'll just add our manager now so we don't have to deal with this later. So drag in your camera manager into the scene and then click play again and the error will be gone. So that looks pretty good. So back into our master camera. We always want to do this check. So let's add a sequence node. If you press S and just click anywhere in the graph, you'll get a sequence node. Okay, so now we want to check if this is the level start camera. So to create that, let's add a variable and call it B is level start cam. Make it instance editable, and then let's add a category for this and just call it camera settings. And that'll just help us stay organized. So that should be good. Let's drag that variable into the graph and then get a branch. So if this is the level start camera, we want to set the view target to be this camera, similar to how we did it for the camera triggers, where we just had this set view target with blend. So all you need to do is get player controller, and then set view target with blend. And then where it says new view target, you would expect it to be able to take in the camera, like camera component, but when you try, it's not going to work. It actually just takes in an actor, so we really just need a reference to ourself. We also want to make this the active camera. So basically anytime in any of these blueprints where we're doing set view target with blend, we also want to make that camera the active camera, which is just that function we created here. So we already have a reference to our camera manager. So if we just drag that in here and then search for our function, SetActiveCamera, just like that, that should be good. And then this also takes in a master camera variable, so we just need a reference to ourselves again. If we click play now, nothing will happen because defaultly his level start camera is false. But if we go in our level and then we click on our master camera, we'll see our setting here. Camera settings is level start cam. And let's just check that to true. So now when we click play, we should expect to see this view. Our player starts kind of over here right now. Let's just move that in front of the camera just for visuals. If we click play, yep, now we see it's using that camera as default. Our camera switch is still working, but like I said, we're actually going to change this to use master cameras as well. Next thing we want to check is if this is a tracking camera. So we're going to be setting up some logic to basically have this camera follow the player wherever they move. So to check if this is actually a tracking camera, we'll add another variable, name it B is tracking cam. Also make that instance editable and then put it in the same camera settings category. Compile. So drag is tracking camera into the graph, and let's do a branch. So if this is a tracking camera, we do want another function now, where basically whenever you have a tracking camera and you're switching to one, you want like an initial snap to the character view. Basically just so that you don't get like kind of a smooth blend from wherever the camera is initially pointing. You just want it to instantly look at the player on the first frame and then follow the player after that. So we need a new function to do that. So if you go into the Functions tab, let's click plus. Let's call this SnapToCharacterView. Okay, so for this function, it's going to be pretty simple. So we'll just set this up now. We want our camera component, so drag that into the function. And then we want our isTrackingCamera variable. Drag off this into a branch. So if this is the tracking cam, we want to set the world rotation to look at the player. So off of camera, let's do set world rotation. Like that. And then to actually get the rotation that you need to point so that the camera's looking at the player, it's pretty easy. There's actually a function in Unreal to do that. So let's get world location. And then do find look at rotation. So that has a starting vector and a target vector. So starting vector is your camera and the target will be the player. So all you need is get player character, get actor location, and then do that as the target. So pretty simple, just like that. We'll just use some reroute nodes to clean things up. And that is it. So that's this function done. So going back to BeginPlay, at the very end of all this, if you are a tracking cam, right off the bat, you just want to snap to that character view. So compile and save. Back in the viewport, if you click on the master camera, and then you set isTrackingCamera to true. If you look at the way this is angled now, you'll see obviously it's this like straight on view, so it's looking pretty much right where the player is. If you could click play, you probably won't notice much of a difference with what we did. It's looking pretty much the same. But if you actually drag our player start somewhere else in the scene, so let's say we're over here, and then click play again, you'll see how it instantly views the camera to wherever the player is. And that's exactly what we want for the tracking camera. When it's a fixed camera, you want that angle that you are setting up in the scene. But with a tracking camera, you want it to initially jump to wherever the player is. But as you see, it's not following the player yet, so we still have to actually set that tracking behavior, which we're going to do a little later. Okay, so that's actually all the logic that we need off of BeginPlay. Before we move on with anything else in the master camera, we actually are going to step back and go into our camera trigger. And we'll update a few things here just to make sure our full system is going to work. So in this actor, under BeginPlay, we're going to do the same thing we did in the master camera where we get a reference to our camera manager. So you can just copy all these nodes over, paste that into the camera trigger, and that should be good. So, and then right click on this variable and just do create variable. Click compile. So that is BeginPlay all set up. Then what we want to do is go to wherever we're actually setting view target. So right at the end here, and just making sure we're not using it anywhere else. So yeah, just these two spots. Like I said before, we want to set the active camera whenever we're setting the view target with blend. So in these areas, we're going to do that. So we get a reference to our camera manager, and then find our function SetActiveCamera. And then we'll hook this up in both paths. So whenever you're setting the new view, we're setting the active camera. But what you'll note is if you try to actually use the active camera here, it's not going to work, or use the enter or exit camera. It's not going to work because this is just a camera type, a camera actor type, and it's not actually our master camera type. So we have to change that. Just find both enter and exit camera here, and then where it says camera actor, we're just going to switch this to be master camera. You'll get this message asking if you want to break connections, and then just do change variable type. Okay, so it looks like that worked. You'll now see the broken connections for these variables now that they're master cams. So all you have to do is just re-drag off of the output and set the new targets to be these variables again. Click compile, and that should be good. So now you should be able to drag off of these variables and just plug them right into new active camera, since these are now master cameras. Cool, so now we're setting our view when it's an enter and exit cam, and we're setting it as the active camera. So the last thing you want to do too is, just like in our master camera where we're also checking if we're a tracking cam, we want to do the same. So we can probably just copy this over. Actually, no, we can't copy it over. I'll show you why in a second. So if you go on the trigger, what we need to do is we have to actually get our isTrackingCam variable from the master camera. So this is a master camera, so if you just drag off of here and then you search isTracking, we'll be able to get that variable. And we can check with a branch if this is a tracking camera. And then we can also SnapToCharacterView, which is a function that's built into the camera. So that's why everything's really coming off of these master camera variables. So let's just reorganize this a little bit like that. Off of true, SnapToCharacterView. All right, so that looks perfect. So let's do exactly the same for down here. Great, and I think that's all we need under our camera trigger. We can probably test this too, so if we go back in the level. Right now, these are not master cameras, so I believe if you click play, and then we run to try to switch the view, yeah, everything's gonna get messed up. So all you need to do is switch these cameras to actually be master cameras. So let's make a few more master cameras. And we can actually probably just copy our exact views from before. You don't need to do this really, you can just position it however you want, but you can just paste the location and the rotation from before. Cool, so then click on your camera trigger, and then now our enter and exit variables are blank, so we just have to choose to use our new master cameras. So it's probably master camera 2 for enter and master camera 3 for exit. And you can rename these later, but this is just for a test. So if you click play, it's going to use our starting camera as the default. And then when you go over the trigger, it'll snap to our new camera and then back to that camera. So everything's working again. Okay, so let's finish doing the logic in our master camera. So all of this is going to happen off of event tick. So the first thing we should do, drag off of delta seconds, just promote this to a variable. We're going to need this later. Let's add a branch. And then let's do a check to see if we if this is already the active camera. So to do that, let's get our camera manager ref. Get current active camera. And then let's get self. And then an equal node. So we'll just check, are we the current active camera? If we aren't, then we'll disable tick. So we don't want tick running, like I said, on these actors when they don't need to be. So if we are no longer the current active camera, it'll just instantly turn off tick. So all you need to do is get your reference to self again, and then do set actor tick enabled to be false. And that'll be the false path. Next, we want to check if we're an on-rail camera. So we created this spline component, which we'll be using for the on-rail camera. And we just need another variable to see if we are actually that. So we have our camera settings for isStartCam and isTrackingCam. Let's just duplicate one of those and then just name it beIsOnRailCam. So drag that into the scene. And then let's get a branch. So if we are an on-rail camera, the first thing we're going to do off the true is set the current rail distance. So we need a new variable, another float. So call it current rail distance. And then we're going to set that on true. And to actually set that and calculate what that current rail distance is, it's going to take a little bit of doing. So go to an empty spot. Let's drag our spline into the scene. And then we need to do get distance along spline at spline input key. So that's the first step. And from that, we also want to do find input key closest to world location. And then that's actually going to be the key. And then to find that, we want to basically find that based on where the player is relative to the spline. So we need to do get player character and get actor location. Like so. And then hook that up to the world location. So that's good there. And then we want kind of an offset on where the camera is to where the player is, because you don't want the camera like right where the player is next to the spline. You want it a little bit behind them always. So to do that, we're gonna actually create an offset. So let's do plus, and then drag off the bottom pin and do promote to variable. Let's name that follow offset distance. And let's set the default value to like -200. Okay, so that should be good. So now we have our offset. After that, we want to set target distance. So to do that, we're going to drag off this pin and do clamp. And then for our target clamp to target distance, the minimum is going to be 0. And then the max, we're going to get that from getting our spline again and doing get spline length. Like so, and that will be the max. Okay, so then we want to calculate our delta and max step. So to do this, we're going to drag off of this clamp and we're going to get a subtract node. And then get the current rail distance. So subtract it from the current rail distance. And then off of that, we're going to get sine node. And a multiply. And then this is essentially our delta here. So let's just add a comment just to keep this super clean. Let's call this delta. And then we want to calculate the max step. So to get the max step, we need a variable called distance follow speed. So let's add a float. Name it distance follow speed. We're going to take that and multiply it by our delta seconds. And for the default value for distance follow speed, let's give it something like 2000. Okay, so this is essentially our max step. And then we can hook that up to the multiply here. So you're multiplying the delta by the max step. Then what we want to do is get the absolute value of our delta. So we get an absolute float node, and then we're going to check if this is less than or equal to our max step. And then if it is, we're going to switch our current rail distance. So let's do a select float. And then before we actually go straight into this, let's just add all of this to the current rail distance that exists now. So drag our current rail distance variable and then do plus. So we'll add those together. And then when the delta is greater than or equal to max step, we will add current rail distance to the multiplication of delta and max step. So we will hook that up like that. And then when it is not equal, or when it's not greater than or equal to, then we will actually just use the clamped value directly into our select node. So this should be right. And then right at the end there too, we also want to clamp it again. So let's get a clamp float. Min will still be 0, and then the max should be our spline length, which is over here. So we can just copy this node just so it's a little cleaner, bring it over here, and then that'll be the max again. Okay, I think that is all correct. So let's drag this back and then just hook this up to current rail distance when we have when we are an on-rail camera. And then what we want to do past that is we want to set the world location for the rail pivot, which is since it's parented right now to the camera and spring arm, it is controlling those two components. So we want to actually set that location. So if you drag your rail pivot into the graph, we're going to do set world location on it. And then after you set current rail distance, then we want to set that location. To find this location, we got to do some more logic. So to do that, we want to get our current rail distance, and we want to add it to our look ahead distance, which we did not create a variable for yet. So on this plus, just drag off do promote to variable, and then let's name that look ahead distance. And then let's give that a default value of like -150. Okay, cool. So that should be good. Then we're going to clamp that again. So search clamp. And then similar to before, like we've done in multiple spots already, we're just going to get spline length, and then hook that up to the max. Next, we want to get the spline, and then do get location distance along spline. And then instead of local, we're going to do world space. And then this will be the distance value. And then lastly, we want to smoothly interpolate to this new location instead of just kind of snapping to it. So the way that we do that is we take our rail pivot, and then we get its current location. So get world location. And then we're going to do a v-interp. So v-interp 2. And then we can do delta seconds for the time. And then we want another variable here, just so we can set this later on. So promote it to variable, let's actually just call it follow interp speed. And then let's make that default to be 5. And you can tweak these settings later if you wanted to follow faster or slower. So these will all be configurable, but this should be good for now. So that'll do our smooth interpolation, and then we can just hook that up to world location. Okay, so now in theory, if we hooked everything up right, which we'll see, I know that was a lot, but in theory this should have our camera follow along the spline. Okay, to actually test this, let's take one of our master cameras. We originally had this checked to be the level start camera. Let's just uncheck that just for this test. And then is tracking camera, let's also uncheck that. And the only thing we'll check is on-rail camera. So this one will be an on-rail camera. The other thing is to like visually see this best, we probably want just one camera view where we can actually see this, this whole spline. So let's angle this like this way a little bit. And let's actually make this master camera the level start camera. And then for our settings under tick, because we kind of had it set where like if this isn't the active camera, it's not going to have tick enabled. Let's just uncheck that temporarily. We'll reset this right away, and then let's set tick to be enabled just so we can actually see this working. So that'll kind of bypass that for now. The only thing it should do is, and we also have to be the active camera. So also we're going to hook this false path up to is on rail camera. This is again just a test, but if you don't do this, you just won't see anything happen. So that should be good. And then in the level, if we click on our spline here and you just press Alt, you can drag out as many of these spline points as you want and kind of modify these to make like any kind of path that you want for your level. But for now, we're just going to do like a straight line. It'll be the easiest to visualize. So we'll just do a big straight line like that. And then let's put the player somewhere over here. Also need to make the camera visible because it's not going to be visible by default. So in your master camera, under the camera, just for debug purposes, let's look up hidden. And then now if you click play, there's our camera. And as we move forward, it is following the spline. Splines aren't visible by default in the engine when you click play, so we can do show spline. Spline. It's either show space splines, and then just do 1. And there you go. So now we can see the spline, and we can see the camera following at a distance behind the player. As you get close to the camera, it kind of moves away from you. And then as you move away, you know, it'll follow you wherever you go. And this will work with any kind of spline that we set up. So we actually, you know, let's just add some curves to our spline just as a test. Do something like that, something crazier. And then click play. Let's just do our debug again so we can see the spline. Yep, and then you'll see it follows the player wherever you go. So this is perfect. This is exactly what we want. Everything seems to be functioning. So we can move on to the next part. But before we do that, just make sure, since we, you know, just purely for debug purposes set some of this, we can just undo. Actually, you know what? Let's keep it for now, because I think the next part you'll actually want to see this kind of debug setting too, because we're going to set up our tracking camera logic, and I think it'll be nice to actually be able to see that. We actually already have an isTrackingCamera variable, so if we just drag that into the graph, we can get a branch. And then right after all of our on-rail logic, we'll also check, is this a tracking camera? If it is, we will get our camera component, get world rotation, and then we will set this as a variable, and let's just call this current camera rot. So current camera rotation, so off the true path, we set that. And then we just want to rotate the camera to look at the player again. So this logic will actually be pretty much exactly what we had in our SnapToCharacterView with like one small addition. So we can probably just copy all of these nodes. Hook this up like that. It's setting the camera rotation, so everything should be good like that. And then like how we're doing here, where we're doing kind of a smoother interpolation, we want to do the same but for rotation. So it'll be pretty similar. All we do is drag off this and do our interp. And then this is actually the target. So for the current rotation, it's just going to be this variable we're setting up there. So just drag that into current. And then delta time is delta seconds. And then interp speed, we can make a variable for this. So do promote to variable, and we'll just call this rotation interp speed. And the default for that can be 4, so we'll just do that. And then hook that up to new rotation. And that should be good. So now all of our logic, I mean, really all of our logic is done. We'll have to rearrange some of these nodes in a second just to, once we're done testing. But this should be good. So is tracking cam, let's enable that just to see, just so you can kind of see what's going on. If we do is tracking cam enabled, so now this is on rail and tracking cam, but we're still using, you know, our level start as the view. So if we click play, now when I move, you can see the camera actually rotates to follow the player wherever he's looking. And then if you move forward, it follows and looks at the player. So this is kind of an interesting combo of both of those things. And we can actually see what that really looks like, not just in this test form. So let's undo this camera as the level start camera. Let's make this one the level start camera now. So it's kind of just going to be the default of everything. And then let's just set up our real logic. So what we had before, we had if this is not the active camera, then we disable tick. So we want that again. And then we don't need to see the camera anymore, so we can just do hidden, camera mesh hidden in game, compile, save, and let's hit play. So yeah, now our follow cam is working. It's following the character perfectly. The character can move forward and back, and it'll kind of keep that distance from behind the player. So everything's looking really good. Cameras are still switching, as you just saw there. So I'm going to set up a demo level here just so you can kind of see all of the pieces working together. At this point, that's pretty much everything for the on-rail and the tracking cam. The whole system's kind of working together, so I'll set up that demo and we can take a look. Okay, so I set up this demo map so we can see the full system working. So just to kind of explain what's going on here, the first camera on the level is our level start camera, and I have that checked. I also have tracking cam checked as well, so it will rotate to face the player, but it is otherwise a stationary camera. It's not going to follow the on-rail. Then once we cross through the trigger and go through the green, our enter camera is going to be this spline camera. So this camera I set up, I just made a huge spline that goes through the entire scene. Just manipulating these curves, you just keep alt dragging and making as many points as you want. You can make some really cool shapes with it. So I have this go through the entire scene. And then you'll note that I extended the spline a little bit past where the trigger is, and you want that because of our offset. So whenever this camera gets switched to, you have a little bit of runway before and after the trigger for whatever your offset value is. And the bigger your offset value, the more space you're going to need. So just keep that in mind as you set up these cameras. And when we get through the last trigger, we're going to switch to this camera, which is just a standard stationary camera. It has none of those settings checked, so it'll just be your classic fixed camera. But that's all three of our camera types, so let's click play and see how it looks. Alright, so our tracking camera is looking good. It's rotating to face the player. If you want to adjust the speed of the rotation, just change those interp speed values, and we can make those instance editable so you can change them per camera. If we cross through the trigger, we'll see our spline camera. And that's looking really great. I love how dynamic these cameras are. Something that would maybe be fun for a future tutorial is creating like a chase sequence using this, which we could make like a kill volume that kind of follows along the spline at a set speed, and then the player will have to kind of outrun it to not die. So if you're curious in a tutorial for that, just let me know in the comments. We could do that in a future one. But lastly, when we cross through our volume, we'll jump into our static camera, and that's our traditional Resident Evil cam. And that's looking really great too. So everything's working. If we cross again, we can go back. Yeah, it's looking perfect. So I think the next thing we'll address in the third part of this tutorial is the controls when the cameras change. Because right now you'll see like the character wants to kind of always come towards the camera when you're pressing basically the down key, or if you're pressing the stick down. And that switch kind of has a little bit of a jarring feeling when you're playing. Like you kind of want to go one direction, but the camera changes and then it makes you go the next direction. So we'll fix that in the next tutorial, and that'll probably be our part 3. So that'll wrap it up for this video. Did you enjoy the tutorial? If you did, please leave a like and subscribe. It'll help my channel grow. If you have any questions, drop a comment on YouTube or Discord. I'd be happy to help. And if you have any suggestions for future tutorials, definitely leave them in the comments down below. So thanks again for watching, and I'll see you in the next one.